So the end of the practice test wants me to find definite integrals. I can get answers on my calculator, but for all of the integrals except for the very last problem, you need to do the integration by hand. So let me start off and find this definite integral in problem 12 by first doing the integration and then plugging in the 1 and the 4. So real quickly, I'm going to rewrite this integral, and I'm going to stop writing the 1 and 4 until I actually need them, just to save myself a little bit of writing. And it's not always so clear when I write those numbers on the integral sign anyways. So I split this integral up into two integrals. That's a constant, I don't need to rewrite it. That has a coefficient, I do need to rewrite this. This first integral, I'm going to write it as 2. I'm going to emphasize times x to the first dx minus the integral of 4 dx. My computer's getting loud, hopefully this is understandable. And now I'm going to integrate this one using the power rule by adding 1 to the exponent, multiplying by that fraction. This one by just tacking on an x. And I'm going to get 2 times, it's going to be times 1/2 because the new exponent's going to be 2. And then the constant just integrates to that constant times 4, so that second integral just integrates to be 4x. Cancel these 2's, and the integral part of this is x squared minus 4x. If I didn't have the numbers on the integral sign, I'd be done and I'd just tack on a plus c. But I have those numbers, so I need to find the area by plugging the numbers in. So I'm going to evaluate the integral at 4 and do 4 squared minus 4 times 4. I can do that in my head, which is probably stupid, but I'll do it and get 0. And then evaluate it at 1. Do 1 squared minus 4 times 1, and I think I could do that in my head as well. So I plug the 4 in, plug the 1 in. Now I subtract the results. The first result was 0. The second result was -3. I subtract the results. The double negative becomes positive. The entire answer that you would type if this is an online Canvas test would be 3. I will definitely go to your work to make sure you have this as the integral. If this was like an 8-point question and you just wrote the answer and didn't show any of the integration, it's probably like -7. So let me check this real quickly. Let me put the function 2x minus 4 in. Make sure I have a good enough window. That's good enough. Second calc, integrate, and I have to do backwards with my numbers on my calculator. So lower limit 1, upper limit 4. I hope to see a 3. I do, so I know my answer is correct. 13, it's another definite integral, so I'm going to need to integrate and plug the numbers 0 and 3 in. I need to integrate first. Let me do the u substitution integration. I'm going to stop writing the 0 and 3 until I need them at the end. It's technically not correct, but it's not really that big of a deal. So rewrote the problem with the parentheses with the exponent first. I let u be the inside of the parentheses with the exponent. Rewrite the problem with a u. Then take the derivative of this. The derivative of u we wrote as du dx. The derivative of x squared is 2x. The derivative of 1 is 0. Either multiply by dx or have skipped this step and figured out that du is 2x dx. I'm going to change that 2x dx to du. So this is going to be the integral of u squared du. I'm going to integrate now by adding 1 to the exponent, multiplying by 1 over the new exponent. Don't need the plus c because I'm going to plug the numbers in. The plus c would actually cancel. Change the u back to x squared plus 1. And now I need to probably really rely on my calculator because I'm going to need to plug 0 and 3 in, figure out what these equal to. Do not want to do this by hand. I'll definitely mess up. So first I'm going to plug 3 in. do 1/3 times 3 squared plus 1 quantity cubed. I'm going to hold off on the 1/3, and I'm going to do 3 squared plus 1 cubed. That gives me 1,000. So this is 1/3 times 1,000. And that's exactly 1,000 over 3, because this is really 1/3 times 1,000 over 1. So I multiply 1 times 1,000 and 3 times 1. Do the same with the 0. Do 1/3 times 0 squared plus 1 cubed. Let me get that 0 squared plus 1 cubed. I didn't need to put the 0 in a parentheses nor the 3 with the exponent in a parentheses because they're positive. The parentheses comes out to 1, so I'm left with 1/3 times 1, and 1/3 times 1 is just 1/3. So I put the numbers into the integral, and now I subtract them. To get my answer, I'm going to do 1,000 over 3 minus 1 over 3. That's just going to be 999 over 3, because you subtract the numerators and you fix the denominators. And for an answer, 999 over 3 is just 333. Let me check this on my calculator. Go to the y equals, enter 2x times x squared plus 1 squared, and then second calc 7, lower limit 0, upper limit 3, and I get perfectly the 333 that I wanted to get. 14 is going to be an ln problem. It's one of those fractions that has a monomial in the denominator that I'm going to rewrite with a negative exponent. And I'm going to get a -1 for my exponent on the rewrite. So when I go to rewrite this to do the integration, I'm going to write it as 2x to the -1 dx. Stopped writing the 1 and the e. I'm going to pull them in when I need them. Bring the 2 out in front of the integral sign and get 2 times x to the -1 dx. Apply the rule for x to the -1. This is going to be 2 times the natural log of the absolute value of x. Don't need the plus c, but I do need the 1 and the e. I'm going to plug the 1 in and the e in. First, I'm going to plug the e in and do 2 times the natural log of e. Then I'm going to plug the 1 in and do 2 times the natural log of 1. Those are positive. I don't really need the absolute values. Let me show you that this is nice. If I do natural log second and divide for e, the natural log of e is just equal to 1. So this first one is 2 times 1, which is 2. The second natural log, if I do the natural log of 1, it's 0. So this is 2 times 0, which is 0. So I did the computations off to the side. Now I just need to subtract 2 minus 0. And my answer to question 14 is going to be 2. Let me check this real quickly by putting 2 divided by x in my y1, doing second calc, option 7. And I have to go backwards, so I need to do the 1 first and the e second. So 1 and then enter, second and divide and e, then enter, and I get that 2 perfectly, so I know my answer is correct. So use substitution because of the parentheses with the exponent. So let me do the integral before I can plug in the 0 and the 3. So I'm going to rewrite the problem with the parentheses with the exponent first, the 4 and the dx written second. I let u be the inside of the parentheses with the exponent. I get u as 2x minus 1. That allows me to rewrite the problem as u squared times 4dx. I'm going to do the derivative of this 2x minus 1. The derivative of u is the du dx. The derivative of 2x is just 2. The derivative of 1 is just 0. I multiply through by dx. and I get du equals 2dx. Not good enough because I need to substitute 4dx. So I'm going to multiply by 2, and get 4 du, get 2 du equals 4dx. So I can rewrite this problem as u squared times 2 du. Now I'm in a good place. I can integrate after I pass the 2 out front. So this is 2 times the integral of u squared du. Add 1 to the exponent and get an exponent of 3. Multiply by 1 over the new exponent. So it's going to be 2 times 1 over 3. And that's really 2 over 1 times 1 over 3. So this is going to be 2 over 3 u cubed. I need to change the u back to 2x minus 1. So this is going to be 2 over 3 times 2x minus 1 cubed. I eventually need to plug in the 0 and the 3, and now I'm bringing back the 0 and the 3 because I'm going to need them. So first computation, I'm going to go 2/3 times 2 times 3 minus 1 cubed. Let me figure out what the parentheses comes out to be by going parentheses 2 times 3 minus 1 cubed. That's 125. So this is going to be 2 over 3 times 125. That's going to be 250 over 3, because I think of the 125 as 125 over 1. I do 2 times 125 and 3 times 1. Second computation, I'm going to do 2/3 and then 2 times 0 minus 1 cubed. That's going to give me 2/3 times minus 1, I think. Let me make sure that's good. So 2 times 0 minus 1 cubed, it is minus 1. And 2/3 times minus 1 is going to be minus 2/3. Because I think of that minus 1 is minus 1 over 1. I go 2 times minus 1, 3 times 1. And so now I need to go 250 over 3, the top number, minus negative 2 over 3, the bottom. The double negative comes out to be a plus, so this is 250 over 3 plus 2 over 3. I add the 2 in the 250 and get 252 over 3. And the answer for this integral is 84. Again, an answer without any work is going to get you almost no credit, because I could just do this. 4 times parentheses 2x minus 1 squared, second calc value, lower limit 0, upper limit 3. Checked my answer. Shouldn't write down a wrong answer, but I should show the work. For question 16, this is the one where it wants us to find the gross area and add the individual areas up. And this is the one where I should have did the part B first. So 16b is going to want me to find an x-intercept, which is going to be important when I go to do part A, sketch a graph to figure out the regions. So eventually I'm going to do a 16a, and I'm going to sketch a graph, and real carefully I'm going to start the graph at 1, I'm going to end the graph at 6, and I'm going to indicate the x-intercept. And to find the x-intercept, I take the 2x minus 6, which is my function, set it equal to 0 and solve for x. I add 6 to both sides and divide by 2. Gives me 2x equal to 6, and then x equal to 3. For part B, I prefer the answer 3, 0 as a point. That's the better answer. But for this purposes, if you just wrote x equal to 3, that would be okay. So now I'm going to sketch a graph. Real specifically, I know it's going to be a line. I won't going to make anything crazy for this problem. So let me graph 2x minus 6. Graph it. I know it goes through the point 3, 0. If I want a more accurate graph, let me find the y's that correspond to 1 and 6 by just peeking at my table. The y that corresponds to 1 is negative 4. So the graph starts down here at 1, negative 4. It goes through the point 30, and then it goes up to the point 66. So the graph is going to look like this, and the graph goes further, past the 6 and preceding the 1. This is the portion of the graph that I really need to focus on, because I'm trying to find an area between the x-axis over the integral from a to b. So over the integral from 1 to 6. So the area that I'm trying to find is this area. I'm going to find this lower area separately from this upper area. So this is a beautiful picture by my standards for part A. Part C wants me to find this gross area. So I need to do 2 integrals in part C by hand. So in 16C, the first triangle, I'm going to integrate from 1 to 3. The function is still 2x minus 6 dx. And I know that this guy is going to come out negative. I'm going to put absolute values on that so I know to make the number positive. The second integral I'm going to do is for the right triangle, the integral from 3 to 6 of 2x minus 6 dx. Let me just do this integral off to the side. The integral of 2x minus 6 dx can be found by doing the integral of 2x dx minus the integral of 6 dx. For the 2x dx, I'm going to pull the 2 out front and do the integral of x dx. And for the 6 dx, it's the constant. That's an easy integral. First integral, I add 1 to the exponent on the x and get an x squared. I multiply by 1/2. The 2 that's out front's going to cancel. The first integral is going to be x squared. The second integral, it's a constant, so it's just going to be x times that constant times x. So for this first integral, I need to get it down to a number. That number is going to come out negative, and then I'm going to make it positive. To figure out the numbers, I'm going to plug 1 and 3 into this. First, I plug 3 into it and do 3 squared minus 6x, which is 3 squared minus 6 times 3. Back to the main screen, 3 squared minus 6 times 3. That gives me negative 9. And then I'm going to do with the 1, 1 squared minus 6 times 1. That's 1 minus 6. I think that's negative 5, but why do it wrong? And now I'm going to subtract these results. I'm going to get negative 9 minus negative 5. And negative 9 minus negative 5 is negative 4. So the integral would come out to be negative 4 for that triangle. I need to make the area positive, change it to a positive 4. That's one of the integrals. The second integral is this integral of 2x minus 6 evaluated from 3 to 6. So for the same integral, because it's the same function, I'm going to plug in 6. So 6 squared minus 6 times 6. That's going to be 0. That's 36 minus 36. And then plug in 3. Get 3 squared minus 6 times 3. And I know that comes out to negative 9. And then subtract these. 0 minus negative 9. That's the same as 0 plus 9, which is 9. So this area is 4. This area is 9. For part C, it wants the total area. And the total area, my answer to part C is just 4 plus 9 are 13 square units. Let me get the answer. Make sure this integral comes out to negative 4. Make sure that integral comes out to 9 real quickly on my calculator to make sure I don't have a mistake. So I enter the 2x minus 6. For the left triangle, I integrate from 1 to 3. And I hope to get an answer of negative 4. Perfect. And I made it positive because I'm doing a gross area. And then the second one, I integrate from 3 to 6. I hope to get a positive 9. Perfect, so my answer is perfect. Got to do those integrals by hand. Oh. So we just did that. I feel like I'm missing a problem, but let me do this, and if I'm missing a problem, I'll make a part 3 with just one problem on it. But I hate to do, but it is what it is. No, maybe this is it. I think this is the 5-6 kind of problem. So for this problem, this is the one where you're allowed to use your calculator. In 5-6, we did everything calculator, and I'm going to give you the picture. So I gave you a picture of f of x, which is a dashed line, and it's hard to tell that this line is dashed, but this is f of x. It's the line f of x equals 2x plus 5. I gave you the graph of x squared plus 2, which is this g of x. And I shaded it over the region from x equal to -1 to x equal to 3. Part A tells me to find the integral needed to find the area. Well, the integral is going to have to go from -1 to 3. And it's top function minus bottom function. The functions don't cross. They won't cross on the test. Top function is 2x plus 5. Doesn't need to be in a parentheses because it's written first. Bottom function, x squared plus 2, needs to be in a parentheses because it's written second. Subtract the functions, put a dx. If this is what you wrote for your answer to part A, I'd be completely content with it. If you cleared the parentheses and did 2x plus 5 minus x squared minus 2 and cleared the parentheses, and you wrote the integral from -1 to 3, wrote the negative x squared first, the positive 2x second, and 5 minus 2 is positive 3 third, that would be a better answer if you could sneak the dx in there than what I have. That's actually what I wrote for an answer, but I'd live with this. This is a safer answer just in case you make a math error here. That's either one of these is good for part A. For part B, I'm going to find the area on my calculator. This is the only one you're allowed to do completely on your calculator for a definite integral. So I'm going to enter this function, 2x plus 5. The first polynomial doesn't need to go in a parentheses, but the second one does. Now second calc, integrate, lower limit -1, upper limit 3, so -1 first, upper limit 3, and the answer rounded to 2 decimals for part B of the last problem for the semester is 10.67. So hopefully that feels, everything feels doable. If you could just master these 17 problems on the test, doing everything by hand except the integration on the last problem should be set in a good place for our test.